Okay, so I'm recording now. So remember what I have just done is just creating this beam on 15 level and these tiny openings on the basement. Okay, so on this elevation, we have small windows. We can copy windows. And the goal today, we will start a section from the foundation level up to the roof, and we will have all these windows there. Okay, so on level 0, I'm going to create a wall. And so just go to architecture, walls, and let's look at what kind of walls we have here. Do you have the same walls that I have? Do you have this exterior brick and whatever? Do you have this? Okay, so open this one, edit type, and let's, we can preview. Okay, so we have all these things here. What is it? Let's edit the structure. So inside we have a gypsum wall board, fine. Then we have a vapor retarder. So here we have included even the something that we are studying in solar design or building science too. So we have a vapor retarder. It's inside the thermal insulation. Then the next layer, it's a metal stud layer. I don't like this. Then we have plywood sheeting. Then we have air infiltration. Okay. Then we have air, and then we have concrete masonry units. And finally, we have brick. Okay, I don't like it. So I'm, let me select another one. This exterior brick on CMU, edit type. And if we start this wall here, we have gypsum board, metal flooring, okay, concrete masonry unit, damp proofing, rigid insulation, and air and brick. Okay, so we can start. We will modify this, but I think this is better to start. So make sure that when we have a heavy wall made of concrete masonry units, you have a core boundary here. The core, it's something. Well, I would use this for the structural layer. Okay, so if we have a concrete masonry unit or we have brick, so this core boundary or this core layer should be the structural one. Okay, so in this case we have concrete masonry units. The category is structure. Okay, and the width or the thickness, it's 7 inches and 1. Well, concrete masonry units, we can decide the width. When it comes to concrete masonry units, the sizes are standard. Okay, and the standard sizes are like this. Okay, so it's 4 inches, 6 inches, 8, 10, 12. So it's always an even number. Here we have millimeters, but the thickness of all these. Okay, so yes, here we can see this picture. And on this picture, we have 4, 6, 8, 10, 12, or well, that's another thing. But it's always an even number, starting with 4, and the thickest one is 12 inch. Okay. It depends. We have to calculate things, but I mean, when we are working with concrete masonry units, it's not something that we can decide. They are standard measures, and when we have 8 inches. It's not 8, it's 7 inches and 5/8. Okay, so in Revit, that's why in this Revit file, the concrete masonry unit is 7 and 123 divided by 2. Yeah, so it's almost 8, but it's not 8. Okay. That Revit has families of concrete masonry units, and we can use this default family. That would be the 8-inch block, but it's not 8 inches. It's 7 something, 7, almost 8, but it's not. So that's the explanation of this odd number, because the standard one is not 8, it's 7 and something, almost 8. So let's keep this concrete masonry unit here as the core unit. Then if we go from the structural element inside, we have this metal furring. What is a metal furring? Yeah, it's something like that. Okay, so it's an air cavity in which we have this metallic structure, very light metallic structure, because we need to hold the gypsum board. So this gypsum board is hollow, and it's attached to something solid, probably a concrete masonry unit, with this element. Okay, so it works this way. We have the concrete masonry unit layer, the concrete masonry unit. It's something like that in section. Okay, and here, if this is inside and this is outside, we have an air cavity. But in this air cavity, we have something. We have this light structure, and this is the gypsum board. Okay, so if we look at the plan, the concrete masonry unit is something like this. And this is inside, and this is outside. We have this layer. This is the gypsum board. And here we have these elements that are attached to this and are holding the gypsum board. Okay, but this is air. And this is air. So in this section, we don't see this element, but in the plan, we would see this element. Okay, so this is what the metal furring means. It's an air cavity, and we have different very light vertical structural elements so that we can attach the gypsum board to this. And at the same time, this is attached to the solid layer, which is the concrete masonry. Okay, so that's the explanation of this wall that we are building here. The width of this is it's a weird number, okay? Probably we will change it. And here, this finish is a gypsum wall. This number should be the default gypsum wall board that we have here, but we can simplify this and place a ½ inch. Okay, ½ inch. Then let's simplify this and type 2 inches. For the concrete masonry unit, we will leave this one, 7 something. And here we have a membrane layer, the damp proofing. It's outside the concrete masonry unit. That's fine. It doesn't have any thickness because it's just a membrane, very thin. So we don't add any thickness here. Then we have substrate. Doesn't make any sense. That should be thermal layer, and it's the rigid insulation. And for the rigid insulation, we have 2 inches. Let's make it 5 inches at least. Okay. Here we have air, so there is another air cavity here. Here we can use the same metal furring because to hold this element, we're going to do the same. Okay, so here, outside the concrete masonry unit, we have the thermal insulation. In the plan view, be here. Okay. Then there's another air cavity, and here we have the external finish. In this case, we have used brick, but I'm going to change that, and I'm going to do this external finish as something made of aluminum. And how can we hold this? When we have an a light aluminum facade, we have, well, it's very easy. It's like hanging something on. Okay, so there's an element that is attached to the structural. We have to pierce the thermal insulation, and then we have to attach this to the solid element. And then if we have a horizontal element like this, another horizontal element like that, like a hook, and then we hang the aluminum layer. It looks complicated, but it's not. It's what you would do in your room if you want to hang your Can you speak up? Because I want to.
That metal bearing that is
The inside one or the outside one?
the inside one, that is usually plan.
Yes.
Yeah, that replaces the wooden star when you still put star in the.
No, here we don't have wooden studs because we have a light wall. We can have a wall made of wood studs. Plywood, and then thermal insulation here. Okay, so this is something light. This is what we have in residential buildings. But this is a commercial building, and we don't have this layer with studs and then plywood. We have the concrete masonry unit. Okay, so this air cavity we have here with the metal furring, it's this. Okay, so this is the gypsum wall. If we remove this board, we would see the metal furring there. But it's not a stud. It's not a wood stud. You could do the same here. Imagine that you don't like the plywood and you want a gypsum board. You could have the furring, the metal furring here, and then you can have a gypsum board there. Okay. But we don't have this. We have a concrete masonry units. Anyway, I'm going to show you this. When it comes to aluminum facades, there is a brand which is Alucobond. Details. Okay, so Alucobond, well, it's something like this. You see that we have this element attached to, this is a thermal insulation, so there will be a nail or a bolt going through the thermal insulation and attaching this to a solid element. So this is the horizontal element here, and then we have something that hangs from this. It looks like complicated, yeah, because they are engineers, and it's not just they have to design this element. but the idea is always the same. Okay, so this is the detail, and they have already solved that detail because they can get rid of water in joints. So it's complicated, but the concept is that we need something horizontal. Well, it's like this. Look at this. Okay, so we have a rail here, we have these elements, and if we want to hang a panel, what do we do? Use this. Okay, so it's the same concept as this, but it's waterproof, it breaks a thermal breach. Okay, so that's why we have to rely on good companies, because they have already solved those details. But if you see here, no, you can't see. Okay, there are different details. In this case, we don't have a horizontal one, we have a vertical one, and we have bolts holding this aluminum. I don't like this. I prefer the option of hanging it with this one. Bolting things at the end have a lot of issues. But this is the aspect of this alucobond facade. Okay, so we have the aluminum element, then we have the thermal insulation. There's an air cavity between the aluminum and the thermal insulation, and then we need something. This would be the metal covering. In this case, it's vertical, holding it. Okay, well, in this case, we have a vertical one and a horizontal one. So it depends on the design. We're not designing this. We're just working with reliable companies, and they will provide us with the design, and they have all the details, and they have Revit families. Okay, so just call Alucobond. Okay, I'm designing a commercial building in New Hampshire for whatever, and they will provide you with all the families and all the details you need. But we need to understand, and they have, this is what I did when I was working. They gave me the AutoCAD files, but now they all have Revit families, and they can even bring you like a sample so that you can touch it and you can understand how it works. So this is what we are doing. We are working with the thermal insulation, then there's an air cavity, and then there's a thin, it's not aluminum, Alucobond is a composite material. And what is that? Yeah, a composite material means that you have different layers and they are stick to each other, so you can't separate those layers because they are yeah, they have used special glues and all that stuff. And what do we have here? We have a very thin aluminum layer. Then we have something that it's like a plastic, it's waterproof. And then we have another aluminum layer inside, or maybe we don't. Okay, but a composite material is a material made of different layers, and then you can't separate those layers because they have been manufactured in a factory, and they are. But if you look at commercial buildings now, they all have this kind of facades, curtain walls, and then this Alucobond. Alucobond is a brand, but these aluminum composite layers, it's mainstream, and you can see this everywhere. Not in New England, because in New England, when they are working with commercial buildings, they are still using brick, like in this building, but there are thousands of examples like this, combining these aluminum panels and then the curtain walls. So we're going to do something like that today. Anyway, I'm explaining the layers of the wall. We have gypsum board. We have this metal fairing here, which is an air cavity with a light structural element. Then we have the 8-inch concrete masonry unit. We have 5 inches of rigid insulation. Then here we have another air cavity. And at the end, I don't want brick. I'm going to use aluminum. Aluminum. And the thickness has to be something very thin, let's say 0.1 inch. something very thin. So click OK. And that's the wall we are going to use. This basic wall, you can rename it or whatever, but make sure that when you edit type, we have all these layers: gypsum, metal furring, masonry units, rigid insulation, air, and aluminum. So the first thing we have to do here is to get rid of the thermal bridge. And that's why we need to understand where we are going to place each thing here. But here we have the aluminum, and in the plan view, we will have the aluminum here, and because now we're working with steel structure. Okay, so how can we deal with this complete masonry unit and the steel? Okay, so we have to make sure that the vertical steel structure, the steel columns that we have used, are here. Okay, so we interrupt the complete masonry unit here. We start the complete masonry unit again. And it's very important that we continue, we don't interrupt the thermal insulation. So we extend the thermal insulation this way. So that here we don't have the thermal bridge. If we interrupt the thermal insulation because we have a steel structure, there will be a lot of issues. So now we have to place the complete masonry unit, the steel structure, to make sure that the thermal insulation is continuous outside the building. And then I continue the bond layer. And I continue the this here. So here we have the air cavity. Okay. But this is important now, and it's about placing the wall in the right position. Okay. So I'm going to place the wall here. Again, don't do it a continuous wall because we have this and we are going to analyze this. So we have to interrupt the wall here. Okay, so as you can see, this is not acceptable. By the way, if you have these bold lines and we don't need it so far, you can click here, these thin lines at the top, okay? And now all the lines are thinner and it's nicer. So this is not acceptable. So you see that this line, this is a complete masonry unit. This is the thermal insulation. What we can see, basic wall, what we can see it's that the wall is upside down, okay, because we want this to be inside and we want this to be outside. How can we do it? If you select the wall and press the space bar, yeah. You turn it upside down. You see? Select the wall, press the space bar, and then you change the order of layers. Okay, because we want this to be inside and we want the thermal insulation to be outside. So what do we have here? We don't want this. Okay, so we don't want. Yeah, look at this. So the complete masonry unit is going through the steel structure, so it's not well connected. Let's look at the section here. I will view, create a section. And now I'm going to look at section 2. Okay, we look at section 2. The first thing we notice is that we don't have any detail. So we can click here, level fine. And here we have all the layers now. And we have to deal with this too. Okay, so you see that we have this steel beam that we have placed here. Okay, so we have the steel column, and then we have the steel beam. So we have to deal with the steel column in the plan, and we have to deal with the steel beam in the section. So what's the right position for this element? Remember that this is the concrete masonry unit. Then we have the thermal insulation, air cavity, aluminum, and here we have the air cavity with the metal fairing, and here we have the gypsum board. Okay. So what would I do? I would make and the thermal insulation has to be a continuous thermal insulation that covers the steel column and the steel beam. So first I have to decide if I'm working in section or in plan, and then I have to change things. So imagine that I'm selecting the wall, and I want to, if this is the thermal insulation, this layer is the thermal insulation, I want it to go through beyond this without interrupting that. So I have to select the wall, I have to move it, and I have to make this point here. Okay, so in this case, you see that we have the concrete masonry unit. Concrete masonry unit has to be interrupted here because we have a steel beam in this direction, but we can extend the thermal insulation beyond the steel beam. Does it work in plan? Let's go to level 0. And in plan, it doesn't work, you see, because here we interrupt the thermal insulation. Okay, so this is the concrete masonry unit, but the thermal insulation is interrupted by this. That happens because the steel columns and the steel beam, they don't have the same size. It can happen. It comes with calculations, so it depends on the loads, the beams and the columns. They don't have to be the same, okay? But I have to make a decision because this is not acceptable. It works in section because I don't interrupt the thermal insulation, but it doesn't work in plan. Okay, so in this plan, what I would do is to, I'm going to select the center of the concrete masonry unit, and I'm going to move it up to the center of this, of the steel beam. We still have this problem, and what I'm going to do is to create an air layer. So I'm going to extend, or I'm going to move the thermal insulation outwards. How much? This distance. I can find out this distance. I can go to annotate, align from this point. Yeah, I think 1 inch would be enough. So I'm going to select the wall. I'm going to edit type, and I'm going to edit all layers. And outside, before the rigid insulation, I'm going to insert another layer and move it down. So before the rigid insulation, I'm going to select another thermal air layer, and I'm going to select here air. And I'm going to make it 1 inch. Okay, so now we have gypsum, metal fairing, concrete masonry unit, air, thermal insulation, air, and the aluminum. And what I want to do now is the same. I want to select the central point of this, and I'm going to move it up to the central point of this. Okay, you see, it's not perfect yet. Well, this is something that in reality, you don't have to change that because you will compress the thermal insulation here, and instead of 5 inches here, you will have 4 inches and something. But I'm a perfectionist, so I'm going to select the type, and I'm going to edit the structure, and I'm going to make this 1.5 air layer, 1.5 inches. Okay, and now I want to move from this point to this point. There you go. Okay, so now I can, the thermal insulation goes, and it's not interrupted by this. And we have another layer here, which is totally fine. I mean, we can have air layers. Adding air to a wall, it increases the thermal insulation, so it's not something wrong. It's only that this thermal insulation is not attached to this concrete masonry unit, and there's an air gap, 1 inch air gap, so it's acceptable. And here I made sure that this air gap, again, it doesn't affect here. Okay, so this is the solid element, this is the gypsum board, so I can't interrupt the gypsum board because I have a column. But I can have this column within some air cavity. So this column is within this air cavity, and there it's within the other air cavity. So that's acceptable. And if we look at the section, in the section, yeah, it's not affected because I have the air cavity here, I have another air cavity there, and that's fine. Okay. So that's it. I'm not just placing the wall and that's it. No, I'm thinking about construction now. And if I'm dealing with different materials, we have a steel structure and I have a concrete masonry unit wall, I have to make sure that this connection is good and I don't interrupt the thermal insulation because I don't want the thermal breach here. And this is the most important thing, that the thermal insulation goes, it's not interrupted by the steel column in plan, and it's not interrupted by the steel beam in the section.